about pointers in connection with 2D arrays. So pointers is considered to be a most complicated topic in C programming, and here the explanation will be done in such a way that we can easily understand the pointers in placement perspective. Now, this is Dr.K.N.Sivabalan, and we will start with 2D array. So, a 2D array is nothing but it's actually a collection of one-dimensional array. For instance, if you have 3 rows and 2 columns, it means that you have 3 one-dimensional arrays of size 2. That is the meaning of it. So, in this case, integer a of 3 of 2. Here you have 3 rows and 2 columns. The above array has 3 rows and 2 columns, but it means that you have 3 one-dimensional arrays of length 2. So that is the meaning of it. So you understand this concept in such a way like this. So you have 3 one-dimensional arrays with size 2. Okay, that is called as a 2-dimensional array. Now, for instance, we have taken an example here. We have 3 into 2, that is a 2-dimensional array. First one-dimensional array has 10 and 20, second one-dimensional array has 30 and 40, and 50 and 60, so on and so forth. Now, when we try to print, and I have given the respective address locations on the right side of the PowerPoint presentation here. So, initially, the address location starts from 1000 and it ends with 1020. Okay, the last element will be stored in 1020. And you can see that the first row starts with 0, the second row starts with 1, and third row starts with 2. Okay, because array initially we will start from 0 onwards. The first element will be stored in 0. So the first one-dimensional array is a of 0, 0 and a of 0, 1. Second one-dimensional array is a of 1, 0 and a of 1, 1. So on and so forth we will be doing that. Now, when we try to print a of 0, so a of 0 actually points to the first element of the first one-dimensional array. So a of 0 generally points to first one-dimensional array, the starting of first one-dimensional array. So starting of first one-dimensional array is the first one-dimensional array is here, the second one-dimensional array is here, and the third one-dimensional array is here. Okay. Now, when we try to execute this instruction, first is a of 0. A of 0 actually depicts the first one-dimensional array starting location. So first one-dimensional array starting location is nothing but the 1000 here. So 1000 is called as the first one-dimensional array starting location. Now I come to the second one. When you try to execute the second one, a of 1. A of 1 points to the second one-dimensional array starting location. What is second one-dimensional array starting location? It is 1008. So second one-dimensional array starting location is 1008. And when I print a of 2, it is actually points to the third one-dimensional array starting location. Third one-dimensional array starting location is 1016. Okay. So this is actually in connection with the representation of pointers here. Now we have to know the equivalent representation of it. So a of 0 can also be represented as star of a plus 0, and a of 1 will be represented as star of a plus 1, and a of 2 can also be represented as star of a plus 2. Now see here. We have seen the previous slide. We will get the same answer here. So star of a plus 0 points to the first one-dimensional array starting location. So first one-dimensional array starting location is, in this case, it is 1000. And star of a plus 1 points to the second one-dimensional array starting location. Second one-dimensional array starting location is 1008. And star of a plus 2 points to the third one-dimensional array starting location. Is 1060. Now, we will actually learn about the various equivalence relations here. A of 0, a plus 0 gives the base address of the 2D array, that is 1000. A plus 1 gives the starting address of the second row of the 2D array. And a plus 2 gives the starting address of the third row of the 2D array. That here, first row, second row, and third row actually points to the respective one-dimensional arrays. Okay. And similarly, when I use star of a plus 0, it gives the base address of the first dimensional array. Base address. That means where the first element is getting stored. That is called as a base address. Similarly, star of a plus 1 gives the base address of the second one-dimensional array. And a plus 2 gives me the third one-dimensional array starting location. Okay. So the output remains the same here. In both the cases, the output remains the same. Okay. So when I use a plus 0 points to the base address of the two-dimensional array. When I use a plus 1, it points to the starting address of the second row of the two-dimensional array. So when I use star of a plus 0, it points to the base address of the first one-dimensional array. So here you will get the same answer: 1008, 1016, 1000. Now the equivalent representation of two dimension here. So a of 0 plus 1 can be represented as star of a plus 0 plus 1 gives the address of the first one-dimensional array second location. So 0 points to the first one-dimensional array and 1 points to the second element of the first one-dimensional array. A of 1 plus 1 points to the second one-dimensional array second location. And a of 2 plus 0 points to the third one-dimensional array first location. Now a of 1 plus 1, a of 1 plus 1. So when I write a of 1, it points to the second one-dimensional array, and when I use 1 to that, it goes to the second element of the second one-dimensional array. Now see here, when I use a of 1 plus 1, now you can see that the pointer actually getting moves to the first one-dimensional array, second one-dimensional array. From that one location to the right. One location to the right is actually, it points to the second element called as 1012. So you will get an answer called as 1012 here. Now we'll go to the second one. Now star of a plus 2 plus 1. Okay. So star of a plus 2. A plus 2 means it goes to the third one-dimensional array. Okay. It goes to moves to the third one-dimensional array starting location. It is 1016. Plus 1 means one location from it. One location from it is actually 1020. So the answer is 1020 here. Now we go to the next one, the equivalent representation. So a of 0 plus 0 to the whole star is actually made as star star a plus 0 plus 0. Okay. So if you want to get the value of that, you can use double stars here. Since it points to two-dimensional array, when you use 2 stars, automatically it will get a value of that. And you can see the respective locations. A of 2 plus 1 can also be represented as star star a plus 2 plus 1, so on and so forth. Now see here, when I try to print the first value, a of 1 plus 1. So a of 1 points to the second one-dimensional array, plus 1 points to the second element of the second one-dimensional array. Okay, when I use star over there, I will get the respective value. So now I move to the second one-dimensional array starting location. When I go to the add 1 to that, it goes to the next location called as 1012, and it will result in 1012. When I use star of 1012, the answer is 40. Now the answer is actually 40 here. Okay, value. Now similarly, star star a of 0 plus 1. Okay, a of 0, a plus 0 points to the first one-dimensional array, plus 1 the second element of the first one-dimensional array, 1004. When I use star over there, now I will get a value called as 20. Now see here, it goes to first location, it's to 20. Okay. Now we will go to the respective quiz here. So what is the equivalent representation of a of 0 of 1? Okay, a of 0 of 1 can be given as a of 0 plus 1. The second option, a of 0, star of a of 0 plus 1. And find the output of the following. Integer a of 2 comma 3. You have 2 rows and 3 columns. Okay, when I use a of 1, a of 1 means it points to the second one-dimensional array. Second one-dimensional array. Second one-dimensional array is actually nothing but the address of 40. Okay. So thanks for watching the video. Have a good day.